Hi everyone, and welcome to this presentation of a concrete application based on the i4Trust architecture and using the NGSI-LD console, ouranos-ws, developed by the DIH Faubourg Numérique. In this video, I'll first introduce the general purpose of this presentation and a brief description of the CO2 Mute experiment. Then, we'll switch to a live demo in order to show how the ouranos-ws console is facilitating the usage of the i4Trust components. So let's start with a few words about the purpose. As a digital innovation hub, Faubourg Numérique has the mission to support SMEs and territories in their digital transformation. More specifically in these hot topics related to data spaces and digital twins, the i4Trust project offers the opportunity to enhance the delivered services and to get ready for larger deployments. That's why our DIH has engaged a significant investment to participate in i4Trust experiments covering various sectors. To go further, we'd like to share our technical knowledge, aggregated in our ouranos-ws platform. And above all, we'd like to leverage the emerging i4Trust community to activate new collaborations and reinforce the capacity to support the fair expansion of data spaces, based on open-source technologies. We've learned a lot, and we also contributed to the i4Trust platform improvements through the deployment of the CO2 Mute experiment, funded by the first i4Trust open call, and recognized as one of the most successful implementation for this first wave of projects. CO2 Mute has been deployed by 3 SMEs from 3 different countries and having 3 different domains of expertise. The goal of CO2 Mute was to deliver a decision-making tool to local governments for analyzing the impact of mobility on the environment, especially the air quality, and better plan the deployment of policies to support the citizens in adopting alternate means of transport and finally reduce the mobility impact on the environment. The experiment has been deployed in the pilot city of Bethune, located in northern France. During 9 months, the 3 involved SMEs have experienced new ways of doing business together, applying the paradigm of the data economy. For this experiment, they all used the i4Trust marketplace implemented and managed by our DIH, and they all used the test iShare satellite to get entitled as trusted organizations, and to receive their EORI and their iShare certificates. As they all have the role of data provider and the role of data consumer, they also all implemented the i4Trust components around the context broker. This framework has supported all the participants, starting with the data scientists from the Italian company Sister, that uses data collected by the powered by Fireware devices, provided by the Danish company Montem. Sister also consumes data prepared by the French company Hostabi, working in collaboration with the pilot city. Finally, the impact indicators, calculated through machine learning processes, are published and consumed by Hostabi to deliver the expected services to the city. Now, let's switch to the demo to see how all the SMEs used the ouranos-ws platform to easily manage their adoption of the data spaces and digital twins thanks to the i4Trust framework. In order to keep it short but comprehensive, we are focusing on only one machine-to-machine data exchange, between Montem, playing the role of data provider, and Hostabi as data consumer, for displaying the air quality measurement, on the web app used by the pilot city. To start the demo, we are going to see the creation of the NGSI-LD entities representing the sensors, installed in the city to collect data about air quality. Here's the Montem workspace in ouranos-ws. This is used to manage all the activities regarding the data spaces and digital twins management. On the left side, we can visualize the data model as a schema of the NGSI-LD entity types, including the links between those types. And on the right side, we can see the existing NGSI-LD entities for the selected type. By clicking an entity ID, we can see all the values of all the properties associated to this entity. From this user-friendly interface, one can easily create and update entities and properties without having a technical knowledge of NGSI-LD. For instance, here I'm modifying the value of the model name, and the console is automatically generate and apply the corresponding NGSI-LD request on the appropriate context broker. I can also use the workspace to navigate in the graphs of entities, thanks to linked data principle. For instance, here I can see all the 4 sensors linked to this model definition. And, just by clicking one sensor entity ID, I can access the selected air quality sensor properties. And it's the same presentation for any NGSI-LD entity associated to a valid context file. The navigation in the graph of entities is based on the relationship properties. And to make it more intuitive, the relationships are presented in 2 categories, the ascending ones and the descending ones. Here, we see that this sensor has an ascending link towards its device model. And in the descending relationships table, we see that this sensor has a link coming from one entity used to manage the collected measurements. Again, just by clicking the air quality observed entity ID, I see all its properties. Especially, the measurements collected by the sensor linked to this entity. And, as usual, the links allowing the navigation in the graph of entities. To finish this part of the demo about context information management, we can show the simple visualization of entities when geo properties are present. Depending on the data model, the geo-localized entities are presented as location pointers, as polygons, or as segments. This leads us to the second part of the demo about the way to design your data models. For all the entities created during the experiment, the SMEs have used the Smart Data Models repository in order to harmonize the definition and the understanding of the shared data sets. For instance, to define the entity type for the data related to the air quality observed, Montem has used the features provided by ouranos-ws to build up the data model. In this definition of the entity type, one can specify that it is derived from a standard repository, and in our case, it is the Smart Data Models. Then, one can provide the URL of the raw definition. We have to pick up the URL from the public website of the SDM. By browsing the repository, we can rapidly find the mutualized specification of the entity type. And finally, we open the raw version model.yaml file and copy the expected URL. Going back to our NGSI-LD console, one has now the possibility to get and to select the properties from the standard model that are the most relevant for the specific business case. Thanks to this reference, if one wants to add a new property in the specific type, one has a direct access to the list of all the available properties from the standard definition. And to better control the relevance of the data that will be managed through a specific model, it is possible to enrich the entity type with some information related to the specific use of some properties. For instance, within the location definition, one can check that it is a geo-property and precise that the expected value for a location is a point, and not a polygon. For the ref_device property, one can precise that is a relationship property and that the expected value is an ID of an entity of type air quality sensor. All these principles can be applied to build up possible complex data models, controlling your graph of entities. After these 2 previous steps, we are now ready to see how to share and trade some of these context data. Again, a company acting as a data provider can use ouranos-ws to easily control the interactions with the authorization registry and with the marketplace. In this last part of the demo, we will also see how the data consumer can acquire the access to the data set, and finally how the data provider can deny the access to the previously shared context data. In its NGSI-LD workspace, the data provider can go to the offer section. Here, one can see all the active offers of the provider that can possibly be used by business partners to consume the related data. In the definition of an offer, one can specify the NGSI-LD type, the HTTP verb, and possibly the accessible attributes, and even limit the access to a list of existing entities. All these parameters are the same ones that the data providers use to create the corresponding offer on the i4Trust marketplace. From this page, I sign in the marketplace as a representative of a data consumer, in our case the company Hostaby, using the right external IDP, among the ones of the dataspace participants. Of course, I have to enter the right user and password combination. And I am now able to discover the available offers, with a special interest in the offers provided by Montem. Then, as a data consumer representative, I can select the offer and check its parameters. Especially from the specific characteristics, I can make sure that this is the offer I have to acquire, in the name of Hostaby, to build a service consuming this data. As everything seems to be alright, I can acquire this offer in order to get the authorization to access the related data set. And after the checkout, I can see that the Montem offer has been acquired by Hostaby. Now from the NGSI-LD workspace of Montem, the data provider, one can check the offer definition. And one can see that a new contract detail has been automatically created. This has been done through the activation service that received the notification from the marketplace that a new delegation evidence has to be created in the corresponding authorization registry. More precisely, one new dedicated access policy has been created, with a permit rule, allowing one business partner to access the data. And in the detail of the delegation evidence, one can verify the associated parameters. Like the ID of the data consumer, in this case, Hostaby, the ID of the data provider, Montem, and the full JSON representation of the corresponding delegation evidence. Meanwhile, as data consumer Hostaby has integrated the air quality data in its web app for the city of Bethune. By clicking one of the location pointers, the NGSI-LD entities of type air quality observed are accessible directly from the Montem context broker, and can be displayed in the web app, because Hostaby is authorized to access them through the iShare protocol. Now, for any reason, Montem, as the data provider, can change the policy rule to deny access to Hostaby. This can be done from the NGSI-LD workspace, simply by updating the representation of the related delegation request, and by synchronizing the changes with the authorization registry. One can check that the policy rule has been updated to deny. After this change in the access policy, if we go back to the web app and refresh it, one can see that the location pointers of the air quality sensors have disappeared from the map, because the data consumer is not allowed to access the data anymore. That's it for this presentation and demo. I hope it has been relevant for you. If you want to know more, or if you are interested in discussing possible collaboration or partnership with our DIH, do not hesitate to get in touch with our team. Thank you.